All right, today we're going to talk about something really cool. A brand new way to make our AI agents way smarter and a whole lot faster. We're essentially going from these frustrating AI traffic jams to digital superhighways. And it's all thanks to this new method called graph-based agent planning, or GAP for short.
So, have you ever had this experience? You ask an AI assistant a pretty complex question, and you can almost feel it thinking just one slow step at a time. Well, you're not going crazy. That's actually what's happening. Even the most powerful AIs out there tend to tackle problems one piece at a time, which, is super inefficient. So the big question is, why is that? Okay, so here's our game plan. We'll start by looking at this AI traffic jam and what's causing it. Then we'll get into a totally new approach called thinking in graphs. This is the superhighway part. We'll see how it works, the huge efficiency gains it offers, and finally, what this all means for the future of AI.
All right, let's dive right into the core problem here. The main reason our AIs feel so sluggish on complex tasks comes down to one thing, what researchers call the sequential bottleneck. Seriously, just picture a massive traffic jam, but it's happening inside the AI's brain.
So what is this bottleneck? Well, it's basically a built-in rule that forces the AI to do just one thing at a time. Think about it. Even if a task has, say, 5 different parts that have nothing to do with each other and could totally be done at the same time, the AI is stuck. It has to do them one after another after another. It's like having a single person on an assembly line instead of a whole coordinated team. And this isn't just slow, it's incredibly expensive. It just burns through time and computing power. So to really get why this happens, we've got to look at how most AI agents are actually designed to think right now. The main method they use is a framework called React. And honestly, the best way to picture it is as a tiny one-lane road for all its thoughts.
Yeah, this React framework is really rigid. It runs in this very strict linear cycle. Step 1, it has a thought about what to do next. Step 2, it takes an action, like searching Google. And step 3, it makes an observation. It looks at the results it got. And it just keeps repeating that loop, one single step at a time until it's finished. I mean, it makes sense, it's logical, but man, it is not fast.
And when you put the old way next to the new way, the difference is it's night and day. On the one hand, you've got the old sequential React method, just plodding along, one action at a time, completely missing all these chances to do things in parallel. But then you have GAP. It's built from the ground up to handle independent tasks all at once, because it actually understands how all the pieces of the puzzle fit together.
And this, right here, brings us to the hero of our story, graph-based agent planning, or GAP. This is the game changer. It's a totally new framework that completely rewires how an AI plans and gets things done. It's what finally gets it off that slow, one-lane road.
So what's the magic behind it? At its core, GAP basically trains an AI to look at a big, complex problem and break it down into a map of smaller tasks. The fancy term for this map is a dependency graph, but really, you can just think of it like a smart flowchart. The AI learns to see, okay, this step depends on that one, but these two over here, they're totally independent. And that's the key. It finally knows what it can tackle all at once. So, the big idea here is pretty simple, actually. We're teaching the AI to stop thinking like it's just checking off a simple to-do list, one item at a time. Instead, it starts thinking like a project manager with a smart, dynamic project plan. It can see the entire project, the whole shebang, from a bird's-eye view, and instantly spot which tasks can be done at the same time to get to the finish line way faster.
Okay, that all sounds great in theory, right? But how does it actually work in practice? Let's walk through a real-world example to make this a little more concrete.
So let's use this question, which comes straight from the research paper. What are the populations of the capitals of France and Germany? Now, a standard AI would go about this piece by piece. First France, then its capital, then its population, and then start all over for Germany. But watch what GAP does instead. The first thing GAP does is analyze the problem. It immediately sees that find the capital of France and find the capital of Germany are two totally separate, independent tasks. It also gets that you can't look up the population of a city until you know the city's name. So it recognizes dependencies. And this is what allows it to group things together into parallel batches, which is the absolute core of how this works.
So based on that quick analysis, GAP builds its strategy. It puts the two independent tasks, finding both capitals, into level 1 and runs them at the exact same time. Then, once it has the answers, Paris and Berlin, it creates level 2 and finds the populations for both of those cities, again, in parallel. So you see what happened? It did the whole job in just 2 rounds of work instead of 4. That's a huge difference.
Okay, so the big question is, does this new way of thinking actually pay off? I mean, how much of a difference does it really make? Well, let's look at the actual data and see the impact of this. Well, it's pretty much an efficiency revolution.
This chart here is all about the trade-off between how well an AI performs and how much it costs to run. And just look at that bar on the far right. That's gap. It's achieving the highest accuracy while at the same time having the lowest expected cost. I mean, that's the holy grail right there. You're getting better answers for less money. And the hard numbers in this table, they absolutely back this up. When you compare it to the old-school sequential models, gap just crushes it. It dramatically cuts down the number of back-and-forth steps, what they call turns, and it makes the final answer much, much shorter. I mean, check this out. A reduction of over 33%.
In those interaction turns, what that really means is the AI needs way fewer steps to get to the right answer. So it's not just about being faster. It's about finding a smarter, more direct path to the solution.
And look at this one, a nearly 25% drop.
In the length of the response, that means the AI is way more concise. And in the world of LLMs, that's a huge deal. Fewer words being generated means lower computing costs. So this makes the AI not only faster, but a whole lot cheaper to run too.
All right, so let's zoom out for a second. What does a breakthrough like this actually mean for the future of AI agents? I mean, why is teaching an AI how to truly multitask such a massive deal?
When you boil it all down, gap really delivers across the board. First, you get higher accuracy, especially on those really tricky, complex problems. Second, you get these huge gains in efficiency. We're talking less time, less money. And maybe most importantly, it teaches the AI a fundamentally smarter way to plan, so it can figure out on its own when to go parallel. And that right there is a critical step if we ever want to solve even bigger, more complex problems.
And that really brings us to the big, final question, doesn't it? We've just unlocked true multitasking for AI. We've literally gone from that clogged one-lane country road to a multi-lane superhighway. So, with that kind of power, what are the truly complex, real-world problems, in science and business, maybe even in our own daily lives, that we can finally set these AIs loose on and expect them to solve?